In today's session, we have the topic Big Data for River, conclusions, lessons learned, and good practices already identified throughout the project activities. Now, let me give the floor to António Sampins from Geotribute, the coordinator of the technical committee representing the lead. The floor is yours.
Friends and families regarding the COVID-19, and I hope that you are enjoying this group of workshops, and maybe they are the best way at this moment to do that transfer of knowledge that was previewed in the project. So since we have a professional translate, I will talk now in Portuguese, and I will begin with the topic about the joint analytical report. Okay, so I will share my.
Can someone please confirm that you can see my presentation? So let's start this session. Let me first start with this joint analytical report. And this is a session devoted to all the work conducted within the scope of the project. And then we will continue with the presentations on specific chapters of this joint analytical report. And I believe this will be more interesting, or at least it will be more important for the coming work. So this is a review of the work done. As I'm sure you remember that the goal of this joint analytical report, it was indeed one of the tasks of the technical committee to give us the status regarding the management of water and the status of water in each of our countries. This is one of the tasks of the technical committee. But this technical committee also has other responsibilities, such as organizing events and seminars like this to advise the partnership from a technical point of view and to support the development of action plans of each partner so as to implement practices. This is the simple framework of our project. In the first phase, we have an inter-regional learning phase, and this is what we are now doing with all the events that will take place during this month. And phase 2 is the implementation of the action plans. And this, of course, based upon the good practices identified in this phase of inter-regional learning. So in the first phase, we developed the joint analytical report. And this will be the backup for the second phase. So one of the objectives of this joint analytical report is to identify the status of the main rivers and water management policies at the local, regional, and national level. And this, of course, for all the partners in the project, and also the identification practices so that within the consortium, other partners can identify that will make more sense or can be adapted to their reality. And based upon this identification and selection of good practices, they will develop the respective action plan so as to develop them, as I've previously mentioned. I believe that most of you are familiar with the Joint Analytical Report and their chapters. The main goal is to have a brief summary of the state of water in what concerns river basins management, and always based upon the community framework. The speaker apologizes and corrects himself, based upon the water directives. Another important aspect is the importance of ICTs, the information and communication technologies, in supporting improving water management and monitoring. In this joint analytical report, we also have the policy instruments that the partners have. And there is an individual fact sheet of each good practice so that this can be transferred to the other partners, and also the identification of the main opportunities for improving these policy instruments that have been identified. The structure of this report is the one you can see here. Basically, we have 7 chapters. The first one identifies the reality of each partner, and then in each chapter we find a more thorough and accurate analysis. In chapter 2, we have the state of play, and the purpose is to have a detailed description of the status of each region regarding the river management. In chapter 3, we have the enforcement of the EU directives regarding water management. So the main one is the European Water Framework Directive. So when we finish the work within the scope of the joint analytical report, we saw that the water basin, whether or not complying with the objectives of the European Water Framework Directive, it is the unit of planning for the management of water resources. This is a reality for all the partners. We see that at the institutional level, i.e., the institutions, entities that are responsible for the management of water resources, there are common features in all the partners. This means that we have institutions and entities that are responsible for the management of water that are regional, interregional. This is the case of CIM Alto Minho, and also those that are national. So this is a cross-cutting reality in all the partners, this existence of entities with different responsibilities from the legislative viewpoint, and also based upon the existing law in each country. So we have this local, inter-regional, and national entities, and there's a hierarchy in the context of water management. Let me now dovetail with the EU directives, and this in what concerns the water planning of the respective basins. It's also important to mention that together with the main directive linked to water management, we also have the transposition of other directives linked to water quality. And these were identified by the large majority of the partners as having been transposed into the national law. So we don't have major differences regarding these two chapters. We don't have big differences regarding the transposition of these instruments and also the management of the resources. What we do have are the differences at the level of the institutions and their scope of intervention. In this case, the differences are bigger. There's chapter 4 that we will focus on this working session, and this concerns the areas where ICTs, information and communication technologies, can support and improve many of the activities linked to the planning and management of water resources. I would not like to elaborate on this because we will focus on this chapter today. The collection of information enables the identification of the existing reality in all the regions. These technologies are used, but with different levels of application and in different contexts. And this is being analyzed by the technical committee, but I would probably divide into 3 main groups the use of these ICTs. And this means that we have sensor-based systems. They do the control of water treatment systems. And then we have the monitoring of water resources, rivers, lakes, etc. And the other group that can be further developed in terms of technology and uses the group of technologies to support decision making. So based upon the existing control and monitoring, they enable the processing of information and also data, enabling swifter and decisions and also better information and data backed up decisions. Regarding chapter 5, policy instruments used, here we also find some homogeneity but with some differences. All partners have a fundamental instrument which is regional in nature, but it's also linked to national policy instruments and European policy instruments. In fact, this could already be expected because it's based upon the water directives that the project covers. In fact, we can see the existence of regional policy instruments, in some cases inter-regional policy instruments grouping regions or municipalities. But there's always an integration with the national and European policies. And this, indeed, in this case, indeed, there's a variation from partner to partner. This is also something that we will cover later on. On chapter 6, we have a description of each good practice by the partners. The good practices that the partner believes that can be transferred to other partners. So this description is done based upon criteria that have been defined. There is a matrix for the characterization of the good practice so that we can have a more homogeneous interpretation of the good practice by the technical committee and the partners. Then, chapter 7. In chapter 7, we have indicators of for the management of water resources, based upon, of course, the Water Framework Directive. Here we did find some differences. The differences are indeed more significant because the way the information is processed, the information that is made available by the different entities in each country. So we have management indicators regarding the number of inhabitants served by water treatment systems or wastewater treatment systems. And we also have indicators that are more technical, namely water quality indicators. So here we can see bigger differences within the consortium, but we also have a different way to do the integration of the community directive and possibly the technical procedures followed in each region. The final chapter is the identification of the stakeholders in each of the partners, the stakeholders linked to each partner, so as to have a notion of all the entities that can influence or advise the partners of the project, and that they themselves can be a recipient of one of the good practices identified within the scope of the project. So this joint analytical report is being compiled. There are some doubts about terminology and layout, but the contents of this report are almost finished. And in the second phase of the project, we will identify the good practices to be replicated by each partner, and also the definition of the action plan will enable its development. So, in green, we have the chapters that will be presented in this panel. And the presentation will be done by the lead partner of each chapter. This is how we organized within the consortium the drafting of the political report. So let me finish. And now, I don't know if there are any doubts or questions, or if we will deal with questions at the end. I believe that now we will have the presentation by the Romanian partner, and it's related with the potential for ICT applications in water management. I don't know if the Romanian partner is already connected and available. Cristobal.
Okay.
Okay, just a seconds to. Can you hear me well? Okay. Thank you very much for being here. Thank you very much for this opportunity to explain what is happening with chapter 4. I'm representative for National Union of Romanian Employees. I try to explain in a brief the state of art in this chapter. Let me share the application, not application, the screen. Okay. Okay, can you see my screen? Okay. Can you see the screen? It's okay. Good. Dear partners, we need ICT solutions in order to monitoring, control, and decision support in management of water by using state-of-the-art technologies. Because we talk about complex ICT system that requires complex hardware tools, precise measures, and complex software in order to analyze from physical parameters to the quality, chemical and biological parameters of incoming outgoing water. So I think it's okay. It's wrong. Excuse me. This one. Excuse me. Okay. In which areas ICT can support? Harmful chemicals and algae are present in the water today on large quantities. Algae bloom that not only lower oxygen level in natural waters, but can produce toxins as well. While algae are important species in water ecosystems by recycling nutrients and thus providing food for the organism, the rapid growth preferred as algae bloom can be harmful not only for the ecosystem itself, but also for branches of economy relying on good quality water. Chemicals that are dropping the water and toxins produced by certain species fungi can have harmful effect on human health and cause significant harm to animals, the environment, and the economy. The ultimate solution would be to keep the composition of the water bodies under control and limit the chemical and substrates of algae, such as N and P form, to an acceptable level by using ICT automate through volumetric water monitoring device and customized software systems that can be capable to detecting, counting, and classifying chemicals and taxon of algae and bigger organisms, and offer alerts and report about them. An effective microbiological and chemical control strategy combines the appropriate testing and the use at optimal intervals. Can you see the water management ICT complex system for a smart water management integrates and analyzes a wide variety of data sources and provides both an intuitive way of visualizing and understanding the patterns and anomalies, and an easy way of acting of them. The result is a view of water or wastewater operations that presents individual systems, devices, and departments. This end-to-end view gives you the key information to need to make better decisions that help lower cost and risk while increasing or recapturing revenue and enhancing customer satisfaction. For decision support system, a very good solution for water management and good practice in Romania, is a sea water ICT solution for efficient water management. An European project FP7 focus on increasing water and energy efficiencies in water supply systems by making use of advanced ICT technologies. The project uses the last wireless technology in order to connecting various types of sensors for real-time monitoring. This information is subsequently used by a decision support system based on a simulation and optimization models for providing most efficient operational strategies. UNESCO is mainly involved in research components related. The project is a collaboration with large industrial partners, Siemens, Toshiba, two water utilities, Metropolitana Milanese from Milano, Italy, and a quantum from Timisoara, Romania. ICT use a smart water management system have a wide application and clear set of benefits, which is in general increase water use efficiency and therefore decrease consumption. Some of major areas where improvement is evident could be outlined in real-time monitoring. Technologies such as smart metering, SCADA, GIS, telecommunication sensors, and decision support systems are effective tools for the provision of real-time relevant data. This means that water utilities have the opportunity to make improvements in demand response and in reducing water losses in the water distribution system. In the field of reduction in water consumption, ICT provides the tools needed to create advanced water use efficiency in all sectors. Incorporation of sensors in agriculture sector ensures that crops are watered when they need, reducing large volumes of water normally lost due to over-irrigation. The reduction in operation cost, improvement in these operational efficiencies mean that administration costs can be reduced, increasing an optimization of expenses. In greater public involvement, one of the benefits of ICT is the improvement in communication between water utilities and the public, which will lead to an enhancement in public awareness with respect to consumption and water usage. Integration of smart water management in smart sustainable cities. Practically, smart water management system is highly incorporated into smart sustainability cities and is a safeguard economic growth and sustain a higher quality of life, as well as it maintain ecological and environmental resources for future generations. The use of ICT products, solutions and systems in the proper monitoring and assessment of the environment flow can lead to better decision making in sustainable management of water resources. This is the conclusion. So now I try to speak about the water monitoring shortly, briefly. That is very important. It's the second main topic in this chapter. Presently, the physical and chemical parameters of water quality are measured online and continuously. However, the biological components of water was only be determined manually using consuming methods such as microscopy. Currently, monitoring biological components of natural and treated water is an extremely hard working, lengthy, and costly manual process. Conventional procedures include manual sampling, transport to biological laboratories, sample preparations, microscopic analysis, and manual documentation of the result. So changes during the transport in physical and chemical parameters are compensated, but microbiological parameters are irreversibly changed as living organisms can die, break down, and become unrecognizable over time. Additionally, the process requires highly qualified biological experts using fixed-base expensive equipment, and to obtain actual results often takes several days. Monitoring ICT system provide automation and accuracy. Automatic recognition and collect data can be easily used for further evaluation regarding the quality of water. So lots of monitoring solutions are available on the market, but few are integrated also with a smart water management system in order to create a complex real-time monitoring and a water management ecosystem. I would like to present shortly this solution, but I think it's better in the second part of this event dedicated to the solutions. I don't know. I try to introduce this solution. One of the great solutions already developed, sensor to net water system, offer innovative and intelligent solutions, data collection, interpretation, design, and implementation by making both monitoring and water management. So this is the answer when monitoring and management of water solution needs to be small, inside populated areas, resource recovery, water reuse, and aquaculture project, and being at community planning. Overall, real-time water quality information is needed. Large number of sensors need to operate in one location, but at great distances for each other. Remote access to sensors data is a must, but installation of cable network would require huge investment. So we have a lot of boundaries of this solution identified. That, but I would like to present in the next intervention. With this, I finished my presentation, and thank you very much for these minutes. I hope to fix the time available. Thank you. I give you.
Obrigada ao parceiro, à União Nacional de Empresários.
Thank you to our partner, the National Union of Romanian Entrepreneurs. And now we will have a presentation on policy instruments, opportunities and needs. And this corresponds to Chapter 5 of the Joint Analytical Report. And this presentation will be done by the Kaunas University of Technology by Jolanta Dvarione. Jolanta, are you? Conseguem ouvir-me? Conseguem ver-me?
Just a minute. Can you see? Yes?
Okay. Okay, can you see it properly? Yes, okay. Thank you very much. So our task in the joint technical or analytical report was to analyze or maybe to compile the information on policy instruments in partner countries. According to the Interreg Europe program, policy instruments could be, or it refers to any policy, strategy, or law developed by public authorities and applied in order to improve specific territorial situation, or of course regarding the water management issues. So what we made, we just collected information from partners, and you can see the summarized information on the policy instruments referred in the application form, and of course provided information by the partners, and and we can see that almost all policy instruments, what we mentioned in the application form and afterwards we were discussing during our meetings, as well this meeting, all partners refer to mostly to regional operational programs dedicated for 2014 and 2020, except two. I would say that from Sweden we have the policy instrument, they refer to regional environmental objectives of Östergötland. And in Portugal, we have Alto Minho 2020 Strategy Action Plan. So always when we start to talk about the policies, about the improvements, and how to make those improvements and influence the decisions in region. Nowadays, it is a question because those regional operational programs where other partners from Spain, Greece, Romania, France, Lithuania, we are referring to the program which is already, I would say, that finished. And a new program, operational program, are going to be developed next year in the, for example, in Lithuania, we have this promise until June, should be approved, the program. Of course, all the efforts in the partnership to collect and to exchange experiences could be used and maybe already was used or were used to develop and to help our policymakers to develop regional operational program for next period for 2021-2027. And what we made, we just, as we have not a lot of time dedicated for just a look to the policy instruments of the partners, we just summarized and dedicated for each country one slide saying what are the main opportunities and needs for each partner. And actually, you can maybe quickly to read, or I just would like to mention that after summarizing all this information, we understood that mostly the same problems exist in each region. And as Spain, they indicated as the most needed or opportunities and needs for improvement of policy instruments addressed a good percentage of funding for water treatment and management, as also for innovative solutions. And they refer that this approach and these needs should be also included in the EU regional operational program. And of course, the main things is still the improvement should be related with the management, with the maintenance and monitoring of water treatment and purification system, new or existing. And these are because the policy instrument is only focused on building those systems. And this is really related with many countries, because we also know that in our country, as an example, we built a lot of new infrastructures, new wastewater treatment plants, but still we have a problems with maintenance and monitoring. So in Greece, for their regional operational program of Attica, they see the opportunities and needs for improvement of policy instruments addressed to also facilities and infrastructure for the supply of island and small agglomerations to meet the requirements. And I would say that this is because Water Framework Directive usually is dedicated for the agglomerations and for the cities more than 2,000 person equivalent. So in all countries, the same problems that we have a lot of small agglomerations, small cities or villages. They use water resources and they produce, they discharge wastewater. And this should be somehow treated, especially in those coastline areas where the problem is eutrophication, as we have in the Baltic Sea. So for Romania, in their mentioned chapter for opportunities and needs for improvement of the policy instrument address, they also mentioned this maintaining the social and ecological parameters of water and aquatic resources, which are defining sensitive elements for the whole society, both in terms of maintaining and living conditions and for economic development. And also they refer for sustainable management to ensure the maintenance of biological diversity and ecological balances, as well supporting water management long-term approaches as an integral part of the system of key areas of sustainable development. And what we note is that actually the same maybe problem has all countries, because sometimes we lack long-term goals, and thanks to Water Framework Directive, because we have some deadlines for substances of very high concern or some other indicated, but still there are no long-term strategies in each country. For Sweden, in there, as I have mentioned before, they refer for their regional environmental objectives of Östergötland plan, and they see that develop new approaches to use the policy instrument to create more administrative indicators that are showing the progress in reaching the goal. They also indicated as a need to carry out local action plans that will be a tool for municipalities to use the spatial planning process. And of course, in this work, new cooperation between actors will be established. Also, they have mentioned more extensive monitoring needs and sensor techniques and data management to sort and transform large amount of data. And along with the local plans, several other areas will have to be developed to support the plans and make the plans more accurate and concrete. And those mentioned local water management or extensive monitoring and data management is needed. On the France, they also made like SWOT analysis for their operational program, and we see that some opportunities and needs for improvement, the policy instrument may be indicated in the weaknesses and was indicated in the opportunities and in some threats. So it is necessary to have sufficient administrative, legal, and financial capacity for using European funds, and this was mentioned as a weakness. It is the role of the local authorities as management authority to properly alert project owners for setting up a project financed by European funds and to continue to support important and risk zones. And also they have mentioned as an opportunity to improve the articulation with other European funds or programs and local projects. And also they see the threats, the differences in interpretation of certain regulatory aspects and the weight of controls, the human resources allocated to the program management, and low processing and payment times. And actually, these could be also the examples for all countries, because we have this problem the same in differences in interpretation of certain regulatory aspects, and especially in some countries, and I think the same as we have in Lithuania, we have different authorities related with the operational program, with the policy instrument, and sometimes these ministries, national authorities, ministries, Ministry of Environment, Ministry of Economy, or Ministry of Finance, they have to decide on the measures, on funding, and sometimes they don't want to agree to one or another case. And in Lithuania, we also see that our opportunities and needs for improvement of policy instrument addressed to our priorities. And of course, I have mentioned that in Lithuania there are updated or upgraded wastewater treatment plants, but still we need to think about especially about the emerging substances, about the substances of very high concern or priority substances. And I think we all can discuss the issues because this is actually problems in all countries, those pharmaceuticals or phthalates or some other specific substances of very high concern. Of course, eutrophication is still a big issue, and we still should take actions and reduce pollution by nitrogen and phosphorus. And to install wastewater treatments in small communities, as was mentioned in other partners' policy instruments, that this is an issue, and especially in touristic areas where the load of pollution is very different. There are differences between the seasonal and non-seasonal pollution. Of course, our opportunities and needs related with the promotion of autonomous sewage treatment system, because we still have a lot of population not connected with the central wastewater treatment networks, and we should promote this and ask some support from the national authorities to try to help this promote autonomous sewage systems. And of course, as I have mentioned before, these settlements less than, or communities less with the 2,000 inhabitants is currently the biggest issue in Lithuania, and because we still these communities were not in the EU financial support under the current financial framework, and this should be also somehow solved. And last but not least, I think the policy instrument mentioned the strategy 2020 action plan for Alto, and they also indicated at the regional level the, an opportunity to strengthen the role of water resources as an essential value to develop of the region in its various aspects, economic, social, environmental, and ecological, and as a strategic asset to be considered at the planning region process. And it will allow the definition of actions of regional nature and promote greater knowledge of the various factors associated with the use of the resource and assure a better response. And this project, there is a need to creation of governance instruments among the different stakeholders that may constitute an improvement in the implementation of that type of measures. And this is expectation from a project. This was mentioned by the partners from Portugal. And that's it. Thank you for your attention.
Thank you, Yolanda. De seguida, terá então lugar a apresentação de boas práticas. Cada parceiro irá.
Now we'll have the presentation of the good practices. Each partner will briefly present the best practices identified within the scope of the project. Please respect the time that was allocated to you. We are slightly delayed, so please respect the 10 minutes which were allocated to you. The first partner will be Sim from Alto Minho by Antonio Sanfins, representing the technical committee. Antonio, the floor is yours. I think you can see my presentation now. So, very briefly, I would like to summarize the good practices identified by Sim Alto Minho within the scope of this project. This is the methodology that we have used. As I said earlier, one of the chapters of the report presented was on the characterization of the stakeholders of each partner. Here at Sim Minho, we met with the relevant stakeholders, and this allowed us to collect the feedback and some good practices. So, based upon this very first draft list of good practices, a pre-selection process was made, and finally we prepare the definitive list of the good practices, which was shared with our partners. And out of that list, we selected the 2 good practices that are more prone to meet the targets of our project. This is the list of the good practices identified. Liliana asked me to be as brief as possible. I had prepared a short description of each one of these good practices, but I will not do it due to time constraints. I would like just to highlight the most important aspects. One of the good practices, the very first one, was a cross-border collaboration in the implementation of projects related to water management in 2 river basins. Well, it's the same river basin, but with 2 rivers, the river Minho and Lima. And these 2 rivers are international rivers. We consider it a good practice because it's related with the cross-border collaboration in the implementation of projects related to water management on risks, quality, and emerging pollutants. Emerging pollutants have been under the spotlight recently, as we all know. A second good practice is related to the regulatory authority for water and waste services in Portugal. They have a portal where you can find an assessment grid of all the entities operating in the sector. So they have very effective assessment methodologies. They indeed assess the performance of the entities in terms of their effectiveness and efficiency, in terms of water management and the management of waste waters. Another good practice is related with the National Irrigation Program. The water use in the agricultural sector is key, at least in Portugal. The southern part of our country has been faced with increasing impacts of climate change. So irrigation is the most important, and we think that this one that we have is a good practice. Another good practice is the SIADD, a system that compiles, organizes, and systematizes all the information on water resources at the national level. This system was presented yesterday, so I will not spend more time elaborating on it. In a nutshell, is an IT tool that has specific databases and it's one of the examples of how we can use ICT tools for our benefit. These systems allow us to collect data and to support decision-making process. Another good practice is related to water quality monitoring and modeling for the preparation of water resources management plans. This good practice was also linked with inland surface waters to assess the quality of those waters and the efficiency of the treatment of those waters. Yet another good practice number 6 on agro-industrial wastewater treatment and energy recovery from wastewater. Another good practice identified was the use of the so-called floating islands. This is a solution for low-cost nature-based solutions in wetlands, namely. This will allow us to ensure a greater level of efficiency in the use of water for agricultural purpose. Another good practice was the applicability of standards ISO 14001 and 31000 on environmental management systems and risk management systems within the scope of water management. And this was also used for the certification of sustainable forest management, because it's important to integrate these forests within the so-called water cycle. Here in good practice, we have now good practice number 9. This is one of the good practice which was presented to the consortium, and this project was presented yesterday. It's the Nor Water project. It's an ongoing project, and it was selected because it meets two important things. First, once again, it focused on emerging pollutants in the waters of Galicia and northern Portugal. On the other hand, this project aims to develop and implement modeling and forecasting tools which are innovative and relevant. In Sim Alt Menu, we consider that IC tools are key. And this is a less visible areas, because here we are talking about the development of databases and the use of AI to support the decision-making process. So we are not focusing here on monitoring. It's important to develop also these databases. So we leverage as much as possible the use of ICT tools in order to promote a better management of the water resources. And good practice number 10 is the CG map, a global system for the innovation and modernization of Portuguese agriculture. Once again, it's all about development of databases, search engines, and so on and so forth, so that we can have more in-depth understanding regarding the use of water in agricultural activities across Portugal. This means that the management entities will have information to make decisions, because as we all know, one can only manage what one knows. You cannot manage what you don't know. It's important to understand the amount of water being used for agriculture purpose, which type of water is being used. So this allows us to have an accurate snapshot of the water use for agricultural purpose. I will not take more time. I have prepared a more detailed analysis of the two best practices which were selected to share with the consortium. But since we are running out of time, and since these two best practices were presented in detail yesterday, so I think that I have exhausted the time that was allocated to me, and then I'll bring my presentation to an end, and I would like to thank you all for your attention. Muito obrigado. Thank you very much, Antonio. I'll give the floor immediately to the next partner, the Regional Development Fund from the region of Attica. Antigone Goffa, the floor is yours.
Antigone?
Yes, can you hear me?
Yes.
Can you hear me? Okay, I had to switch between the applications for the translation and the presentation here. I start sharing the screen. Where is it? Okay. So, okay. Do you see my screen now? Okay.
Yes.
All right. Both the practices presented on behalf of Region of Attica have to do with monitoring for all the purposes described from the previous speakers. We all have impacts because of climate change. We all have high demands on quality and quantity of water supply. Ecological status has to be maintained and improved. So you are familiar with both the good practices I'm going to present here. I'll just go as brief as possible through the main questions that we are to answer for this, the purposes of this presentation. So the first one involves monitoring of a supposed river basin, chemical assessment of emerging contaminants was the main thing. Involved all the pollutants, the monitoring of all pollutants. And the second good practice was presented last Tuesday, and it was about water quality monitoring with the use of robotic boats. So about the first good practice, monitoring of a supposed river basin, I'll remind you that it's solely funded by Region of Attica, and it was elaborated by the National Decapodistrian University of Athens. The main objective was to monitor the extent, to have an extended monitoring of water quality of a supposed river basin and its underground aquifer at the borders of Attica, and Mavrosovala Spring, which provides drinking water. The overall aim was to obtain a database for the qualitative and quantitative assessment of the levels and the origins of the pollution of the waters of a supposed basin, assess the environmental risk, and propose actions to improve water quality. Why was it considered a good practice for us? Well, for starters, a supposed river is an interregional river, and there is extensive industrial activity taking place near Attica's region borders. There have been pollution incidences in the past, and an extended environmental monitoring study is necessary. So we wanted to include determination of legislated compounds of priority pollutants and emerging contaminants, and have a very good and thorough and in-depth monitoring of the ecological status and any pollution being transferred. We consider this good practice tested and mature since it has been concluded in October 2020, and through it, it was realized the implementation of a well-structured sampling campaign. All samples were screened with a within-house target database of the University of Athens. Advanced chemometric tools were applied for the detection and identification of contaminants. The directives were used for the quality assessment of physiochemical parameters, conventional and priority pollutants in water supplies. And the risk assessment study was applied for investigating the potential ecotoxicological threat of the detected emerging contaminants. What were the main results obtained? Well, thousands of emerging contaminants and their transformation products were screened. A list of compounds that should be monitored in a regular basis was compiled based on their frequency of detection and their ecotoxicological properties. The monitoring results may be used for chemical management purposes. And as for the main difficulties that we had to tackle, first of all, we needed a continuous operation of the auto samples, as well as a good operation of them in the field. So we needed to be autonomous on power supply, and solar panels and batteries were required. Of course, the auto samples had been well organized and tested before starting the sampling campaign. Safety issues were tackled. There were no endangerment because of winter conditions, because of climate conditions during winter. A very vital and of high importance issue was the good cooperation with local people. They were the ones that helped a lot in sustaining the operation of the auto samplers, and they help a lot collecting information on land use, enterprises, and activities taking place in the area that had to be incorporated in the study. When advanced monitoring of water bodies for pollutants and emerging contaminants is necessary, the replication of this good practice could offer a lot, going to an in-depth monitoring of pollutants of all kinds. You need state-of-art analytical equipment, highly expertised researchers in analytical chemistry, high-resolution mass spectrometry. Of course, the Laboratory of Analytical Chemistry of University of Athens is both willing and able to assist, collaborate, train, whatever effort to that direction. So going to the good practice number 2 for region of Attica, which is the water quality monitoring with the use of robotic boats. It was presented in detail last Tuesday, as mentioned earlier. I'll keep very brief that the project brings together tools to meet needs of stakeholders concerning the water quality using autonomous boats with a set of sensors incorporated, and it supports decision support system too. So why was it a good practice for us? It's a better water management. It helps better water management with innovative and efficient systems, technologies, and techniques for water monitoring. The application of robotic boats and their integrated sensors allows monitoring and sampling of water quality in large areas of lakes, rivers, and includes monitoring areas that are not easy to access. The impacts of anthropogeneous pollution can be thoroughly investigated with the use of the robotic boats. It provides systemic full-scale application of INCAT's tools in the future that can collaborate, complete the current tests for monitoring the quality of catchment, greatly reducing the cost. And a more thorough monitoring strategy, both in space and time, optimizing solutions for monitoring the water bodies. We consider this good practice also technologically mature and tested. The robotic boats have been tested on field. In the field, they carry a basic set of sensors. They can be enhanced with an innovative set of sensors for monitoring a greater variety of parameters. And they also can carry up to 4 containers for taking samples on the field. So the water quality monitoring was applied in one lake, and a more short-term deployment on demand in 9 other water bodies, demonstrating the benefits of the application of robotic boats. That involves monitoring of ecological status more accurately, with emphasis on phytoplankton growth, more thorough monitoring campaign both in space and time, and significantly higher amount of water quality data without requiring labor-intensive and costly schemes. Collection of many discrete samples, representative coverage of the catchment required for chemical classification, and online monitoring tools provided sufficient data to allow for the accurate calibration of a water quality model used for evaluation purposes. The main results obtained. Okay, we have autonomous and ready control of the boats. As mentioned earlier, they can cover bigger and broader spatial extents in a shorter time in comparison with field survey techniques. We have fast and flexible data collection, safe and easy data organization and storage, convenient data collection from no easy access sampling areas. Innovative sensors make monitoring easier and cheaper. Low lab equipment requirements, improved management of the site sampling plan, provision of spatial distribution data, and safer working environment. Decision support system optimizes the water quality monitoring, and the cloud-based georeference data management solutions support sharing with the whole community and raising alerts in time. Some of the tools that one needs to use don't need high expertise, but there is the use of tools that the stakeholders may need, and you actually need someone with greater expertise on that area. So it depends, the difficulties depend on the request from the stakeholder. Thanks to the ability to use on-site measurements using appropriate sensors, and they are relatively easy use, the robotic boats could be valuable and extremely useful in dams and low-flow areas for comparison with automatic telemetric stations. in comparison and cooperation, let's say, with satellite images for monitoring areas, enhancing monitoring programs for water systems requiring a high frequency of measurements, significantly reducing the number of samplings and the costs without damaging the quality of the data. Through real-time measurements at various points of the body to be monitored to enhance the ability to detect early pollutants. A daily basis for many companies, such as port management and companies that have strict environmental conditions and are close to the sea or some other water body. Companies active in the monitoring of surface and groundwater as well as liquid waste. Here I conclude the presentation of the two good practices chosen for region of Attica. I hope I didn't exceed the time given too much. Thank you all for your attention.
Thank you, Antigone. Passaremos de seguida então ao parceiro.
Now we will continue with our partner in Sweden, from the County Administrative Board of Östergötland for water, Sara and Sofia.
As well. Okay, so I'm going to start sharing. Let's see. Okay, so I'm going to present the good practices identified by Sweden that we've included in the jar. I would also like to just remind everyone what we agreed on during the technical committee meeting, that we were supposed to adapt the texts for each good practice to the table that Portugal used. I have added the document to the Google Drive, so if everyone could just adjust their good practices in there, we will be on track with this chapter as well. Thank you for that. So I'll start presenting the first good practice that we have identified, and this was presented by Sofia during the first meeting in Athens, but we'll remind you about it again. This is a local action plan for the river Tinnebecken. It is located close to Linköping, and it starts in agricultural area, and then it flows through the city and connects to another river, and then reaching a lake called Roxen. The plan for this, or the reason to develop this local action plan, was a holistic approach due to the fact that the city is expanding, and the areas surrounding the river are supposed to be taken into use for buildings. So it's 6.5 kilometers long, so it's quite a long stretch. So as I said, the Linköping municipality intends to exploit large areas, including a former military exercise area, which could contain like PFAS and such. So it's very important to take into consideration everything that could be associated with the exploitation. It primarily concerns housing, construction, and trade, and the small river of Tinnebecken has currently moderate ecological status. When the plan was developed, it actually was in bad ecological status. And the municipality are responsible for meeting the EQS of the river. So that's also a part reason for developing this plan, and by developing measures. So the state is that the plan is actually already done. It was published in May and is in use for both water management and city development plannings. The development and application method was that there was evaluation of existing data, monitoring, measurements were done to complete this, and also some modeling for hydrological events and such. And the effects and benefits of this plan is both economical and environmental, of course, because you don't have to develop a lot of small plans for each development, and the EQS hopefully gets improved. So the main results is, as I said, one plan for the entire river instead of multiple small plans, which also gives a better view of the situation in the river. It's also a bit more cost efficient. You can divide the costs of developing the plan for all of the areas instead of each area having to be developed part by part. It also developed a library of possible measures to be taken to both improve the ecological and chemical status, but also counteract impacts from urbanization and such. So the main difficulties that we have found was the modeling was very difficult for the consultant making this report, both the availability and insecurities in the models as well. Of course, it's a model, so some sort of insecurity is always there. But we have considered that the potential for replication is in all European waters. Of course, it's beneficial for waters where there's a risk, and also when there's plans for development in proximity to waters, it's both for risk management and cost efficiency. So the second good practice, I don't think we have mentioned to before, it's removal of pharmaceuticals from wastewater. And the reasons for developing something like this is that most operational wastewater treatment plants, I think both in Europe and in Sweden, does not treat pharmaceuticals. For example, the wastewater treatment plant in Linköping, located, you can see it on the picture, has been treating it since 2007 for 180,000 person equivalents. So the reason for treating pharmaceuticals is that the design of the substances usually is meant to persist the conditions in the human bodies until they're reaching their intended place of action, meaning also that it's difficult to remove the ones that actually enter the wastewater from excretion and such. And there is also been identified effects in the environment, such as antibacterial resistance from MRSA, and biological effects in fish has been observed, like reproduction difficulties and behavior changes, from example, from psychopharmaca. I'm not sure about the English term there, sorry. So the state of the good practice, as I said, is that the full-scale ozone treatment has been fully implemented since 2007. The application of it is that it is located in the treatment of the wastewater. After the biological step, there's like a pretty complex method that I'm not going to go into details, but for the ozone, the water enters the tank where a small part is relocated into a biflow where the ozone is applied, and then the biflow is then relocated into the main tank, and it flows through and get mixed with the rest of the water flow and is then released into the next treatment step and ultimately into the recipient. So this is just a small main results. The removal of the pharmaceuticals in the wastewater that's been removed is 90%. It depends a little bit on the complexity of the water, since the ozone actually also reacts with nitrogen. So the dosage has to be adjusted accordingly. So the main difficulties is actually the ozone consumption. If there's a lot of nitrate, the ozone gets consumed by nitrate as well, and also by dissolved organic carbon. So the dosage is varying, the demand is varying in relation to the DOC and the nitrate, and this creates problems in constant reductions of the active pharmaceutical ingredients, the APIs of the wastewater. But the potential of replication is, of course, as well in all European waters. We see that has impacts from wastewater treatment. And important to say is that it's not only humans that excrete pharmaceuticals into wastewater. It's also been traced to veterinary products that is applied in our animals. So that would be all. Thank you.
Thank you, Sara. De seguida, teremos então a Universidade de Tecnologia de Kaunas, que nos irá apresentar as suas boas práticas. Portanto, chamamos novamente a intervir.
Thank you, Sara. And now we will have again the University of Kaunas, and we would like to invite Jolanta again to take the floor.
Once again, okay. Can you see?
Yes.
Okay, and now? Okay. Okay, so I will start. First of all, of course, with those two good practices we presented in a joint analytical report, and we used this summarizing tables of two practices just. But I will talk a little bit later about what else we have to propose for our partners and what was identified while, because this is, as I understood, this is a continuous process, and we are contacting our stakeholders, and we are discussing, and we are getting news about new things. So, but still about the floating island for nutrient removal, and actually this was, for me, was very nice and very interesting. And the reason why it was considered as good practice, because the constructed floating island are increasingly applied for water restoration and creation of natural floating riverbanks. Greener coastal cities contribute to nutrient removal capacity. And actually this technology is not new, and we know about the wetlands, about the capabilities of plants to accumulate the pollutants, not only biogenic compounds, but also other compounds. So what is the state of this good practice? This good practice was implemented, and nutrient removal by floating island would contribute to overall water quality management in the coastal area of southeastern Baltic Sea. And this is, of course, very, I would say, the expression that very huge contribution, but I would say that by installing small, even small floating islands, we can definitely reduce, and we can start with the local water bodies, with the small water bodies or artificial water bodies, where is the problem nutrients. And you see the main results obtained, and it is presented. And the owner of this good practice, they didn't identify main difficulties, and maybe we can mention that, of course, this is seasonal. Seasonal purification of water body, because in Lithuania at the moment we have a snow and we have a winter, and everywhere is icy, and so it means that no purification, but of course, those lagoons can help those floating islands can help to decrease the contaminants and especially nutrients. And of course, if you want to know more about the projects, this was a project in Baltic Lagoons, and you can visit the project website and get more information about the details and maybe other results. Because this one good practice was presented from Lithuania, but you can find a lot of from other countries as well, because this was used in several European countries. Next one was also mentioned by our colleague from Klaipėda University on the first day when we met and a little bit talk about the good practices already. So solutions for storm water management, and this reason why this was considered as a good practice, because the surface runoff treatment improve water quality using this solution and ecological status. And this good practice already installed and operates, and the Pastalninkas stream collects the flow of 253 liters per second from the area of almost 10 hectares surface drainage, while only the most polluted wastewater flow needs treatment. So main results obtained: the following natural wastewater treatment processes in treatment facilities: settling and filtration of suspended solids, organic material absorption on the plants and soil, microbial degradation and assimilation of organic compounds, uptake of nutrients and metal compounds in selected plants. And they also didn't indicate any difficulties to what they had during the installation. And solution could be also replicated in the regions for surface runoff treatment to improve water quality and ecological status. So this is also a very short presentation on that, but I think in more in details was presented by the colleague from Klaipėda University, and you can find in the slides. I hope that those slides will be shared with the participants. So when we were discussing with our partners and we saw that what kind of good practices were selected, and especially, of course, our project is dedicated for ICT tools, and we started also to contact our stakeholders in Lithuania, and I know that these companies like NIT Baltic, and NIT is I think around the world, and the company providing ICT for management and for other purposes, different solutions. So using GIS, we can manage water networks on real-time data from sensors. It could be used for public awareness and data and app sharing about the water supply and server networks, prevention of accidents in the water networks, asset management, and flood hazards and risk maps, to develop the cadastre of rivers, lakes, and ponds, for water quality in surface waters, for water level monitoring and prediction, and monitoring of achievements in environmental projects as well. So, and actually, one of the examples, and I contacted our company, Kaunas Waters, Kaunas Vandenys, and they shared with me the GIS application for Kaunas water management. And actually, this system is integrated information management technology that enables to provide cartographic data about the underground networks belonging to their company, and their associated attribute material. This is a real opportunity to provide the company's employees with detailed visual information, not only about water supply and wastewater facilities, but also to use the data of the State Enterprise Center of Registers and the data of National Land Service and data from other companies operating underground networks. And there are small, I put it from the one PowerPoint presentation, all these small maps shows what are the processes, what the processes manage, and what are the processes integrated in their information system. So this is really very nice and very interesting and very useful good practice for water management in city. And one of those examples from our partners I presented during the visit and our meeting in Athens last January about the Mid-Baltic. They, as I said before, they have a lot of developed projects, different projects where ICT tools used in different management, data management, and they call intelligent network management systems for water utilities. And they have several projects in Lithuania with different cities. With almost all, they have developed their own intelligent systems in each city in water companies. So that's it from my side, and thank you for listening. If you have some questions, I will try to answer to those questions.
Thank you, Yolanda. Passaríamos então rapidamente ao parceiro.
Let's now continue with our next partner, the National Union of Romanian Entrepreneurs, with Cristobal Toro. Cristobal, the floor is yours.
Can you hear me well?
Yes.
Perdona, Cristóbal, não te estamos ouvindo.
Cristobal, we cannot hear you. Cristobal, can you hear us?
Cristóbal, no te oímos.
Cristobal, can you hear us? We cannot hear you.
¿Me oís, Cristóbal?
Luísa, não se- consegue fazer.
Desejam que eu.
Sim, estamos com um problema técnico por parte do.
And the presentation will be done by António Sanfins, and then we will go back to our Romanian partner if the technical conditions so allow us. I think you can see my screen now. Okay, again, thank you and good morning on behalf of the Iberian Association of Riverside Municipalities of Douro River. I will do the presentation of the good practices that have been selected until now. The methodology was identical to the one that was followed by SIM Alminho. We did an online questionnaire to the different municipalities that are members of the association so as to identify possible good practices. Then we had meetings with the stakeholders and we had a preliminary idea of these good practices. So 2 of them are of a more methodological nature and 1 is more technological. In the case of our association and within the scope of the partnership of this project, Big Data for Rivers, as the name itself explains, this is an international association. So we considered from scratch that this could be an added value for the project so that these good practices would reflect the international character of the association. And the purpose from a wider point of view was to ensure our approach in terms of a water resource that exists in 2 countries, Portugal and Spain. So there's a whole series of issues and also the sharing of responsibilities and also competencies that all this arises before any technical issues. As I said, we considered that it would be valuable for this Big Data for Rivers project to share this experience with you. So regarding the second and third good practices that we've identified, it's related with this. The first one is related with the management, the shared management between Portugal and Spain of the entire water basin of the Douro River with concerns regarding water quality, but also the volume of water in the river. And this is indeed one of the most important parameters in this sharing of responsibilities. Portugal and Spain have an agreement, a specific agreement for the sharing of water basins. It's not only the water basin of the River Douro that is shared between Portugal and Spain. So this sharing of responsibilities is well defined, as I've said, with several agreements made between the two countries, clearly defining which are the entities involved in the management of each water basin, in this case of the Douro River, which are the entities representing each country, which are the competences regarding the management of the river, the validation of quality, and it's not only physical, chemical quality and bacteriological quality, but also the environmentally adequate water volumes of the river so that the ecosystems of the water basin are not jeopardized. And this involves all the entities. Regarding outcomes, this sharing has enabled us to share outcomes, and both in the national plans of Spain and Portugal, this is integrated in the water basin planning of each country, and also the type of monitoring that is done and the type of information that is shared. So this is a well-established, fully fledged practice between the two countries, and it can be replicated in all rivers, or better said, water basins, where there are different countries involved. And when we talk about different borders, it's the borders of one country or one, two, or several countries. I will skip through the second good practice because it's very identical. It is related with a joint program between Portugal and Spain for the definition of the hydrographic plans of the hydrographic water basins that we have in common. It is directly linked to the Water Framework Directive, the EU Water Framework Directive. There's also a concern to ensure, in this case, all matters related with quality and water volumes. Right now, we are producing ecological data, and it's also developing methodologies. And this aspect is not so technical in nature, but it is important before we use techniques or technologies. We need to define the methodologies. So the main outcome is the management and coordination of this water basin management so that we ensure the ecological diversity and EQS. So, but these are fully fledged, well-established practices that can be used by other partners that have identical situations when water basins are shared with other countries. The other good practice is related with an information system throughout the water basin of the Douro River, and this is related with the monitoring of aspects related with the ecosystems that are needed. And it involves the monitoring of the river flows and where there's areas where there's the risk of floods, and identifying the more sensitive areas, and also the river behavior and the ecosystems depending on the river flows, and also enabling when there are floods a management of the flows throughout the water basin of the Douro River, preventing floods in neighboring populations, and also to have very small flows that can jeopardize the existence of the fish stock. So with the use of GIS, not so much for the physical, chemical quality and bacteriological quality of water, the management of the existing infrastructures. This is a river with several dams, and the managing of these infrastructures and of their respective flows, and being able to predict the areas of flooding and taking action before this happens. This is how this automated information collection system has been set up, and it is an example of the management of water resources, which is not only linked to the chemical, physical, and bacteriological quality of water. We are working with the main stakeholder, the association, the Iberian Association of Riverside Municipalities of Douro River, that's the board of Castilla and Leon, so as to identify other good practices that may also be submitted to the partners, namely when we have our field visits in Spain. Again, thank you so much for your attention. If you have any queries or questions, I believe there will be a Q&A period in the end. Thank you so much, Antonio. Let's again try to reach out to our Romanian partner, Cristobal. So we still have this sound problem. So our colleague in Romania still has a sound problem. So while we try to sort this out, I think we should start our debate. I don't know if you have questions for our partners. So apparently there are no questions. Everybody is duly clarified on what was presented. There are no questions.
No.
Oh, Liliana, Liliana e Luísa, eu também estou com problemas.
I'm also having some problems because I submitted a question, but I cannot send it to all the partners, so the app is blocked. So I cannot share the question. I believe that several good practices have been presented. Therefore, it would be interesting to validate or to have your first impressions regarding the best methodology to follow so that partners may choose a good practice so as to back up an action plan. So, what are the criteria? Because these best practices are very diversified in nature. So my question is, what would be the criteria, in your opinion, that we should have, and should they be global or specific, so that a good practice can be an action plan? I can see
Não sei se alguns
again, let me ask if one of our partners would like to reply to challenge that Antonio has just made to us all.
Olá.
Olá.
Want, if I have time.
Perhaps Cristóbal, por causa
Sí.
del tiempo de que el presidente está aquí,
Ok.
acabamos y depois voltaríamos à tua apresentação.
Ok, sin problema, no hay problema.
Os problemas técnicos da ligação que tivemos, de facto, conduziram aqui algum atraso. Portanto, depois desta partilha de resultados, e voltaremos novamente ao parceiro da Roménia, passaríamos agora a palavra ao Sr. Presidente da SIN Alto Minho, José Maria Costa, que nos irá fazer aqui o encerramento desta jornada de trabalhos.
Muito bom dia a todos. Good morning, everybody. It's a pleasure to be with you. And first of all, I would like to thanks to all the people collaborate for this event. In particular, to all the secretariat of SIM Alto Minho, but also for all the partners. And we are very grateful for our collaborators from other institutes and institutions collaborated with this event in these days. It's a pleasure for us to permit with this work to achieve more knowledge about the correct useful of the water like a resource, and we are very concerned about the future with the climate change and other things we know together, and we are very interested and know and profit all these kind of events to promote the best ways to make the water a final resource with the best application possible. Thank you for every people. I hope so a very good year for all. Tomorrow we start in Portugal a new lockdown for everybody. Is a very hard month without no life outside. Is very hard for all the people, but we need to protect the health of our populations. Thank you very much for everything, for your work, and thanks for the knowledge we have profit in these days. Muito obrigado a todos. Muito obrigado, naturalmente, em primeiro lugar, à equipa da.
Thank you, everybody. I would like to thank the SEAM team for organizing this event. I would like to thank our partners and the entities and institutions that collaborated with us so that these meetings could attain the aim purpose, so as to use better water, which is a scarce resource. And I truly hope that together we can do more and better to preserve and protect this resource that is so important for life. Thank you. I wish you all a great year. And those who are starting the lockdown now, let's hope that this will be a short lockdown. And I hope that together we are able to overcome this difficulty. I wish you all a nice day. Thank you to the chairman of SIM Alto Minho. And we apologize for changing the foreseen agenda, but we had some technical glitches. And now we will have the presentation from our Romanian partner, Cristobal.
I think now is, are you hearing? Okay?
Yeah.
Okay. Practically, this solution was presented before. So if you give me 5 minutes, I can present this very interesting solution implemented right now in Romania. So can share. Okay. It's talking about sensors. It's talking about water monitoring solution from data collecting, and it's very interesting because Plus is artificial intelligence. So briefly, very short time, I would like to see the water monitoring system is an automated flow-through volumetric monitoring device that is capable to detect, count, and classifying taxon of algae and bigger microorganisms. So this water monitoring system is linked also with another technology from this company in order to be more efficient and potential. So It's a new approach in the field of microscopy and chemical analysis. Excuse me. Because it's using a volumetric analysis method instead of the conventional 2D approach. This technology used the 3D approach. How it works? So this technology is a wireless data collection and AI-based analytical system. So offer a comprehensive services. So the data of water quality is collected by the system and evaluated by a customized professional algorithm, which provide information of efficiency and utilization. Users may use this information for various purposes, such as to improve the quality control, increase efficiency, monitor production processes, apply predictive maintenance instead of cost, and time-consuming traditional service. So using this wireless technology, transmit the data from the measure points to the server, where specifically installed application perform automate the artificial intelligence and the analysis. Elements of sensor TrueNet are individually operating units linked to the standard systems. It's very important, and which responds to the challenges of the industry 4.0 on a high technological level. Okay. The sensor continually collects and transfer the data with it's very easy to install this hardware and software. The wireless communication system without a cabling or GSM subscription, or even without internet usage, if communication goes customer's own internet network. So it is very interesting. This is the many. Some of is what presented before this slide. Some boundaries about the solution. And it's very interesting to be implemented in some countries with these needs. I think it's the last and it's enough. So where the application should be implemented. This is you can see some of the sectors, more important sector where this solution is implemented right now. I think with this slide I can finish the presentation very shortly. Thank you very much for this opportunity, and we have more time to discuss about this and more. Thank you.
Thank you, Cristóbal.
Thank you, Cristobal. This brings us to the end of our panel, and actually to the end of this seminar. I hope it was a fruitful seminar to all the participants, for those that were familiar with this project and for those that were not familiar with this project. I think, well, I hope that you can continue engaging with us. Since indeed we are running late, we will not have time for the debate. If you have any questions, please forward them to the project team, and I will move on immediately to the closing session. Thank you to all of you. A very good morning. I think we can bring this session to an end. I would like to thank all the speakers, partners, moderators, and guests that were with us during this week. Thank you very much for your engagement and input. I would like also to thank Interactive and Global Voices for the translation services. I think thank you all, and I wish you a great week ahead.